Good morning, students. Let's discuss the chapter Organic Chemistry. We were on different topics of isomerism, students, and reaction intermediates. Now, today I'm going to discuss the electronic displacement in covalent bonds. What do you mean by electronic displacement, student? Electronic displacement means, or we can say, when there is a covalent bond in an organic molecule, electronic displacement is shift of electrons, which is due to the presence of an atom or a group of different electronegativity, or under the influence of some outside attacking reagents. So whenever in a carbon chain any attacking reagent or any electronegative atom is being attached or any electron releasing group is being attached, there will be a displacement of electron, right? And that displacement of electron is known as electronic displacement. And this led to a number of effects, students, and these are the following effects: inductive effect, electromeric effect, resonance effect, and hyperconjugation effect. But today I will deal with the two, that is inductive effect and electromeric effect. Now, what is inductive effect, students? The process of electron shift along a chain of carbon atom due to the presence of either electron withdrawing group or electron donating group is known as inductive effect. Students, whenever we have a carbon chain and at the end of this carbon chain, if a withdrawing group is being attached or a electron donating group is being attached, there is a pull and push, right? And there is a shift of electron due to this pull and push. Clear to you? And whenever an electron withdrawing group is attached, that is known to be minus I group. And if electron donating group is being attached, that is called a plus I group, right? This is a permanent effect, students. As you can see in the picture, if there is a carbon chain and one electron negative atom, right, whose electronegativity is quite high, and it shifts the electron towards itself, being more electronegative in nature, as you can see in this picture. So we can say the polarization of a sigma bond due to the electron withdrawing or electron donating effects of adjacent group is called inductive effect. See, now the direction of displacement is shown by placing an arrow head midway along the line representing the sigma bond, right? Suppose this is a carbon chain and one Cl group is present at the end of the carbon chain, which is electron withdrawing in nature. Now it will take all the electron towards itself, being electronegative, and carbon will acquire the positive charge here, right? The magnitude of electron displacement goes on decreasing with the increase in the distance of carbon. Mind this thing. And this effect decreases as the distance from the electronegativity of atom increases. This is a permanent effect and almost negligible beyond the two carbon atoms from the active group. So we can say, based upon this, we have two types of inductive effect. One is plus I effect and second is minus I effect, right? Plus I effect means push the electron towards the carbon chain, right? Because a donating group is being present at the end of carbon chain. And minus I effect means pull, to attract the electron towards itself, right? So we have two types, plus I and minus I, and moreover, whenever a donating group is being attached at the end of a carbon chain, it is known as a plus I group, and that effect is known as plus I effect. And if an electron withdrawing group, right, or more electronegative group is being attached to the end of the carbon chain, it is known to be minus I group, and the effect is known as minus I effect. I have already discussed with you which are the electron withdrawing group and which are electron releasing groups. See, again I am discussing with you which will show the minus I effect such as nitro, cyanide, carboxylic acid, all the halogens, F, Cl, Br, I, OR, OH, these all are the groups which show the electron withdrawing group, which are very electronegative in nature and which attract the electron towards the carbon chain, right? From carbon chain towards itself. And plus I effect means if in a carbon chain, at the end of the carbon chain, any donating group is being present, such as methyl, ethyl, propyl, all these butyl group, all these groups are present. So it will give electron to the carbon chain, right, students? And if and it repels the electron of the carbon atom chain away from it. Remember this. And as the distance increases, both the effects decreases, either plus I effect or minus I effect. See, now what are the applications where you can utilize this plus I effect? First of all, it explains us about the acidic strength of different molecules. Second, the stability of carbocation can be explained by plus I effect, as we have already done the stability of carbocation, that which carbocation is more stable. And I have told you, more the methyl group or more the donating group is being attached to that carbon containing positive charge, more is the stability. So out of 1 degree, 2 degree, 3 degree in methyl, you know, the 3 degree carbocation is more stable because carbon has to complete its octet. It is deficient in nature and 3 helping groups जो है बेटे जल्दी से उसका पॉजिटिव चार्ज खत्म करेंगे और उसकी डेंसिटी बढ़ाएंगे कार्बन पे, जिसकी वजह से उसकी स्टेबिलिटी एनहांस होगी. And acidity increased by the presence of minus I group effect. See students, acidic character means टेंडेंसी टू रिलीज एच आइंस, और अपने में से कौन जल्दी से एच आइंस रिलीज करेगा, जिसके साथ इलेक्ट्रोनेगेटिव ग्रुप अटैच होगा, विड्रॉइंग ग्रुप अटैच होगा. क्यों? क्योंकि अगर हमारे किसी भी ग्रुप के साथ इलेक्ट्रॉन विड्रॉइंग ग्रुप अटैच होगा तो क्या करेगा, इट विल टेक अवे ऑल द इलेक्ट्रॉन, इट विल rather pull the electron from the carbon chain and make that OH group weaker. See, you can see in this case like Cl, CH2, COOH, ऑक्सीजन और हाइड्रोजन का बॉन्ड टूटेगा तभी एच आइंस रिलीज होंगे. वो क्यों टूटेगा? जब हमारे पास कोई भी उसके साथ एक विड्रॉइंग ग्रुप अटैच होगा, लालची ग्रुप अटैच होगा, राइट? जितना ज्यादा विड्रॉइंग ग्रुप अटैच होगा वो जल्दी से एच आइंस को रिलीज करेगा, और जितनी जल्दी एच आइंस रिलीज होंगे एसिडिक कैरेक्टर बढ़ेगा. The same way, if donating group is present with the molecule, it will increase the electron density on carbon atom and OH bond will be a stronger. वो dissociate नहीं होगा, right? It will remain intact only, and the acidic character decreases. So we can say that electron withdrawing group increases the acidic character and electron donating group decreases the acidic character. The same way we can find out the relative basic strength of two different molecules, right? Suppose we have ammonia and we have amine, students. These both are base in nature, but which is more basic in nature if you want to find out. So if any plus I effect means any plus I group is being present, it will increase the electron density of nitrogen atom. That's why the basic character increases. And if the drawing group is being present, it will decrease the basic character. Acidic character and basic character are opposite, students. Please try to understand. Next is again inductive effect depends upon the electronegativity. As the electronegativity of carbon atom increases, the with it increases with electronegativity, acidic character also increases. But as the distance increases, it decreases the electron effect. The inductive effect decreases, as I have shown you, students. So out of fluorine, chlorine, bromine, and iodine, electronegativity of fluorine is more, so acidic character of fluorine is more. But as the distance increases, inductive effect either plus I or minus I, it decreases. And I have shown you the value of pKa. pKa is just opposite to that of Ka. Ka means dissociation constant, means how easily it can dissociate to convert into H ions. So it is opposite to that of Ka, that pKa. So this is summary. Acidity increases with plus I group, basicity increases with. So No, acidity increases with minus I group. It's minus students. Here we have minus I group, and here we have plus I group. Please change this. We can change this. So please correct this. Here will come acidity and here will come basicity. राइट, ये बेसिसिटी को ऊपर ले जाइए बेटे और एसिडिटी को नीचे ले जाइए बेटे. ठीक है, ये बाय मिस्टेक ऑपोजिट हो गया है दोनों. नाउ इलेक्ट्रोमैग्नेटिक इफेक्ट. Electromagnetic effect is another effect of electron attracting tendency or releasing tendency. It is a temporary effect which operates in organic compounds. Students see, it operates in a multiple bond which contain double bond or triple bond. It is a temporary effect and it occurs whenever a attacking species attack on the molecules outside attacking species. And as a result, one pi electron pair of multiple bond gets completely transferred to one of the bonded atoms. See, so electrons of pi bonds are loosely held in this case, and whenever a compound having pi bond approached by the charged reagent, either electrophile or nucleophile, the electrons of the bond are completely polarized or displaced towards them. You can see that. See this picture, you will understand how the displacement occurs. And it is a temporary effect, as I have told you, and it occurs in unsaturated compounds only. And in this compounds, in this effect, there is a complete transfer of pi electron of multiple bond. Now we, based upon that, we have two types, that is plus E and minus E. So in plus E students, if we have one unsaturated compound and if pi electron pair of multiple bond is transferred to the atom to which the attacking reagent get attached, then this effect is known as plus E effect. As you can see here, H ions being कार्बन कार्बन में सपोज एक कार्बन के पास पॉजिटिव चार्ज है, एक नेगेटिव चार्ज है. तो ये पॉजिटिव H आयंस हमारे पास कहाँ अटैक कर रहा है? उस कार्बन पे अटैक कर रहा है हमारे पास, राइट. उस मल्टीपल बॉन्ड ऑफ कार्बन पे अटैच होगा जहाँ पे हमारे पास क्या है बेटे, electron richness है. So it will attach to that carbon. So if the attacking reagent get attached to that carbon having double bond or triple bond is known to be plus effect. And if it is opposite to that carbon, it is known as minus effect. As you can see. See this example. Here out of these two positive, these two carbon atoms, this carbon take away all the electrons. Now H positive will move to that carbon which is having electron richness, and it is known as the plus E effect. And if it is away from the attacking reagent, that is known to be minus E effect. So here I have compared the inductive effect as well as electromagnetic effect. As you can see, it is a permanent effect, it is a temporary effect, there is no such requirement, and here attacking reagent is being required. This requires only a polar covalent bond. Here there should be a unsaturated compound. It means one or more multiple bonds. Electron transfer shown by the arrowhead of midway, and electron transfer shown by the curved arrow, right? So there is no such application of electromagnetic effect as we have with inductive effect. I hope you have understood. Thank you very much. We'll discuss more questions related to inductive effect in our doubt session, students.